How's everyone doing today?
Good.
Excellent. Love the energy. We're going to keep that going. All right. So how many people, quick quiz here, because teacher, I love giving pop quizzes because I know you all love them. All right. Raise your hand if you've ever programmed in Python before. I want to see all the hands if you ever programmed in Python before at all. Okay. I had like a lot of this. All right. So some of you were like, I did hello world. Does that? Maybe. Right. So, and that's okay. Even if you don't know a lot of Python, we're going to talk about a lot of Python in here, but we're not going to get into the details. So it's going to be a heavy, more of an overview of some of those things. We're going to try and demystify all of this stuff. Now, you may have heard a lot of things over the last 2 days. How many people have ever heard of agentic AI before coming here? All right, a lot more hands, right? So this is all the buzz right now in cybersecurity. We're hearing about this all the time, agentic AI. And I want to look at a couple statistics. We used to call them shock statistics back in the day, but everything is so shocking anymore. Nothing is shocking. So, some statistics, I think they're interesting. We'll talk about 74% of IT security professionals report their organizations are suffering significant impact from AI-powered threats. I did a presentation here at Harrisburg University 5-6 years ago in 2019 about AI threats. Back then, was just a couple machine learning algorithms figured out if you had a GPU on your computer that was hacked, it would mine Bitcoin. If it didn't, it would then ransomware, crypto. That was as intelligent as it got. 5-6 years later, we're seeing a lot more AI threats, phishing, malware, you name it, and many of the things we'll talk about today, threat vectors can do as well. 75% of cybersecurity professionals had to modify their strategies last year to address AI-generated incidents. No longer do we have the epidemic of Nigerian prince emails. They're a little more sophisticated. You're not going to find a misspelling anymore. You might a little bit, but not as much. And that's the majority of cybersecurity tools are still 40 to 45% written in Python. That's going to be important for what we're going to talk about today. So, because I know those were so thrilling, even more statistics. 75% of security professionals report that automation reduces time spent on manual security tasks. We all know that. And with AI, we have a lot of opportunity to automate more. 68% have seen productivity improvements through automating processes, and 97% fear their organization will face AI-generated security incidents. One of the biggest things I've seen this year from this, a lot of companies I've worked with, is actually a lot of fake people applying to jobs. A lot of AI-generated deepfake Zoom call people that don't actually exist. So we're seeing that more and more. That's now a threat to the organization. You are now brute forcing or attacking the HR or hiring process. It takes a lot longer to hire people, to get the right people. It wastes companies' time, money, resources. It's a new kind of threat we haven't really dealt with before because we didn't have robots applying for jobs before, not like this. So, with all that being said, in AI, we turn the focus to how can AI help us? So thinking about from a pen testing, a red team perspective, if you will. What if our red team, or outside contract helping me hire, will be running AI agents 24/7, constantly probing our defenses for weaknesses? That's the whole reason companies get penetration testing services to begin with, other than compliance reasons, which is probably number one. But number two is, do my defenses work the way I think they work? Are my configurations in place correctly? Do I have an AWS bucket that might happen to reveal all my clients' credentials to the world accidentally because we clicked the wrong checkbox? Those are things we want to know. But if we have a way to automate and do that automatically, that would be beneficial for us. Saves us a lot of time, a lot of money, a lot of effort. Now, flipping to the defensive side, what if our SOC chatbots that could automatically triage every single alert 24/7. How many people in this room have spent way too much time looking at log file, looking at alert, trying to figure out, what does this mean? I get that PowerShell executed, but I don't know what this goobly gop means. And many of us who have sat in a system analyst chair or been there have experienced that at some point in our career. And if you're a manager, you've experienced someone expressing the frustration of this in your career. And AI can help with this with some caveats, and we'll talk about that. So the agenda for today, we're going to define what exactly is agentic AI. The definition is a little squirrely, as we might call it. We'll talk about the agentic tech stack. Specifically in Python, we're going to look at a simplified example. And when I say simplified, it's going to be very simplified. There's a lot of ways we can expand it. There's a lot of different libraries coming out all the time. We're going to look at one that's simple and works right now. We're going to talk about how you design AI agents. The right way, if there is a right way of design. And then we're going to talk about cybersecurity, AI use cases. So before we get to that, if you can't tell, that is not me. That's just a picture of me. I'm right here. But my name is Brandon Keath. I'm a professor of cybersecurity, senior security engineer, been in this field way too long, over 18 years. I have 3 master's degrees because I love school and torturing myself. I specialize in ethical hacking, Python programming, and posing for the camera, cybersecurity strategy, and compliance. So let's talk about understanding agentic AI. If we break it down into key components, what are we talking about here? Oh, skipping ahead. We're talking about autonomous decision making, which from a security standpoint is already a little problematic, but we're talking about AI that can make decisions without human intervention or assistance. So already we're taking the human potentially out of the loop a little bit. We're talking about something that can learn, runs into mistakes. Instead of someone having to stop it or figure out what's wrong, it can adapt to those changes. Goal-oriented behavior, it's going to do whatever it can to achieve its objective. It should be able to interact with the environment, or from a programmatic standpoint, external APIs and systems. It should be able to do some complex problem solving. We've been able to do simplistic problem solving and scripting for over 2 decades plus now. We don't need that. We have complex problems. The world is complex. And real-time processing. We should be able to analyze AI data and react quickly to challenges we face. So what's that look like? Well, to break it down a lot simpler than that, because that's just a bunch of words on a page and doesn't really convey a lot of understanding, really, we can break it down into 4 key steps. So first, what's the data we're looking at? We're looking at some kind of area of data, right? Is that login data? Is that some kind of log files? What are we doing? Is that red team analysis, Nmap data, whatever it might be? Then we need to run it through some kind of analysis and decision making. We're going to need to give the AI an idea of what is correct. Now, when Google used to train their AI, before Gemini was a thing, they actually used chess, was one of the key areas that they used to train, because the goal was checkmate. So there were clear, defined rules, and it could go through every single potential possibility to get to the end result. The same can be said, even using large language models. When we're designing an AI agent, we need to set clear rules. When we don't set clear rules, we get unexpected output, hallucinations, all kinds of things can go off the rails. We can ask the AI, what's a good vacation spot? And it starts telling us about the history of olives in Italy. Not exactly what we wanted, but it's trying. So the other thing that we do, once we have that, is our output. Is it giving us the correct output? Wherever we can, we should tell the AI or agent parameters around what output is correct. And we'll look at one of the examples I have in a stock trading bot and what would be the correct or incorrect output it would learn for that. So what are the things we need to give the agentic AI in summary? Whatever are inputs or data to analyze, whatever the patterns or processing to look for, what are the patterns of success, if you will? What should it look like when you have that success or failure? And what's the feedback? Because this is going to be key. It's not agentic and autonomous if it stops there. It has to feed back into the cycle. It needs to learn. All right, so going to do a fun example. How many people here trade any stocks? All right, more than I thought. So agentic AI, one analysis, right? If you're doing something that's going to do decision making, we can look at stock trading as an example. You're collecting market data, you're analyzing that data, and based off the price, if it goes down in a certain period of time, that might be a signal to buy now. Or if the price goes up, it might be a signal to sell. And it might do that based off previous history, certain marketing trends. Seems like a really good fit, right? To monitor stock performance and do that. So I wonder if anyone is making an app to do this. And if you actually look online, there are several of these types of apps already. In fact, many use cases like this, just AI stock trading, I started with this premise, oh, this could be a good fit for AI stock trading. I wonder if anyone's doing that. And there is this #1 search in Google right now for AI stock trading that does just that. Analyzes market data, tries to figure out based off algorithms and history and current economic events, what's the best way to buy and sell. Now, that being said, even if the AI executes all this properly, that doesn't mean you win, because fortunately, this would be great because we could all just go home right now and quit if this would win and just enjoy our AI stock trader. But that's not quite how it works. But you can see the example of the problem. We lay it out in this way. We can solve all kinds of things. So how do we use it in our organization? First, we have to describe the common problem we have. And this is no different from when we're trying to automate anything. Many years ago, automation and Ansible took over the IT industry. But one of the issues a lot of organizations had, before we can automate something, you have to know how to solve the problem manually. Because you get really confused when you're going through the steps to automate and you actually don't know a step. The same can be said about AI. AI is not just a magic box, although that's how it appears to many. We put things in, we don't know what we're going to get out, but maybe we'll get what we want out, and we'll just keep trying until we get the right answer. When we're talking about agentic AI, we need more guardrails. It's not like just ChatGPT or Gemini, because more things can go wrong in our AI stock trading program. What if all of a sudden it starts selling or buying a lot of stock and the stock just keeps free falling? And all of a sudden your account is empty before you know. Things can go off the rails. Things can be unpredictable. So you have to have constraints. So you're going to do these actions to X point and put areas of human interaction. We also have to understand there are going to, no matter what we do with agentic AI, there's going to be risks of things going wrong, because the way that hallucination and AI algorithms work, there is not 100% way to stop them from happening, at least not right now. Some of the latest from OpenAI said they figured out a way to get rid of the hallucination problem in ChatGPT entirely. But it would break the algorithm, so it would not work at all, which is the same as not really using it. So that's not a solution to the problem. So no matter what, and this is important when we talk to executives, business owners, when we're talking about agentic AI and cybersecurity, any kind of use case in your organization, there's going to be security risks. because we have to say, if this goes wrong, what happens? And if the answer is that's an okay risk, if it goes wrong this percentage of the time, that's okay. That's what we do as security professionals every day. We handle risk and we let executives know what the risk is based off our analysis. Same thing when we're building out agentic AI. All right, that's the prelude to the fun stuff, because you're all here for the fun stuff. So let's talk about Python, agentic, agent code stacks, because I love talking about code and code stacks. So for this example code stack, which we have to go home and try today for free, which I recommend doing because it's a lot of fun and interesting. We're just using Python. We really need that, really, really do, to make this work. We're going to use Gemini's, which I spelled Gemini wrong, API. That's how you know it's not AI generated. I wrote it and got it wrong. It's not human. Gemini API through Google AI Studio. It is free. There is an API you can use, and generally in this testing, you probably won't go above the free tier. You're going to need sys, os, dot, env, uv, and the Google Geni library, which Geni for Gemini. So this is our code. And I know some of you are like, Brandon, you asked at the beginning, I didn't raise my hand, or I went like this. This is a law. And that's okay. We're going to step through it a little bit at a time, just to give you an idea. So at the top, do I have a laser pointer? I do. Cool. If I, no. There we go. All right. As long as I don't hit the wrong button. So this stuff up here, this is our libraries. So that is code someone else wrote. So in programming, anytime we're importing something, for most languages anyway, specifically for Python, we're taking code. Sys and OS are default. Google is from Google. So Google has created a Gen AI library for us to use their large language model. And then .environment is going to read our API key, because good cybersecurity professionals would never, ever put their API keys in the source code, right? Yeah. Right? So in my example, I am using good programming practice. For all of those watching on the video, I am. For those who called me out 4 or 5 years ago, that's for you. So then we're looking at args. We're taking the, there you go. Can't help but hit the wrong button. We're taking argument, which is the first thing we enter in on command line. So we're used to using nmat, used to using any command line functions. All we're doing is args equals sys arg v1. That's saying, hey, the first thing after you run a command, take that in. We're putting it as argument 1. We're saying if you enter no arguments, which is what, if not args, say, hey, AI coding assistant, enter your prompt here. Here's the example. Promise I'll stop doing that by the end of this presentation. So for user prompt, we're entering in, we're using our API key, and we're sending whatever the prompt is. So we're taking it in as input. No prompt is given, we're doing example. And this is super important. We're printing out our prompt tokens and how many tokens we've used. Why is keeping track of our prompt tokens important?
You don't want to go over in case you incur extra billing.
Right, absolutely. So prompt tokens cost money. So most AI platforms, no matter what, it's going to cost money to run these things. However, all of the example here, even though we're using Google Gemini, you can do with Ollama locally on your laptop or desktop. So Ollama is a way you can use things like Hugging Face, use models locally. Will they be as accurate as OpenAI or Gemini? Probably not, because your computer's AI MPU is not going to be as powerful, but maybe close to the results you want, which may be good enough. So that's all that. This is, we're configuring, we're using Gemini 2.0 Flash 001. This can be really important because even if OpenAI or Gemini goes to their latest model, you don't necessarily want to go to that model, and you might want to use certain models that cost less per token. So that lets us specify that. So let's see how that works. And so this is how that code works. Python main. If we don't do anything, we see enter your prompt here. How do I build a calculator app as an example? And I have it in parentheses so it doesn't confuse the command line. So I said, when did the fall of Rome happen? And Gemini gave my response, which was a non-answer, no single day. She was specified on a single date. So I asked, what's current stock prices? This is interesting too. So the model I have cannot or will not access real-time prices. So I tried to see if it would give me a generic price based off today or the current prices. And this specific model would not. And this is where APIs and integrations make a lot of sense, right? Because depending on the model you're using, it may not be able to access suggestions, real-time data for whatever you're doing, right? So your Python app may be longer depending on how many integrations you have. Now that was still only about 20-ish, 15, 20 lines of code. That's not a lot. And we have our AI chatbot essentially right there. So it's no wonder in the last 2 years that we're seeing AI products and implementations all over the place because the big vendors have provided a pretty easy way to build these AI agents. So now when we design the AI agents, as I said before, I kind of covered this already, but we want to define the agent's purpose, establish those guardrails, whatever limitations. We can do that in code, in our Python code, right? If you come back with this result or the answer is this, I want you to stop. We have lots of ways to do that in Python. We have contains functions, which we can scrape our results back. We have certain constraints, lots of ways to do that. We also want to encourage planning among team members. Why it can feel like FOMO, there's this fear of missing out among companies. People don't know what the acronym means. We should, as cybersecurity professionals, always be skeptical and take a step back and say, hey, I get that everyone's implementing this, and I get that we need to, but let's breathe for a second and plan the best way out to do this. And if there's any risks we need to consider. Integrate those useful tools. There are lots of APIs for real-time stock prices. I keep going back to that example, but it could also be integration to your SIM or your alerts or your antivirus. There are lots of APIs that integrate directly with your tool where you can get that information and then use AI to act on it. Transparency fosters trust by involving humans in critical decision making. It's important that we are getting things to be autonomous, but there may be lots of examples where an AI agent is going to take an action, and it makes a lot of sense for there to be a director, a manager, someone that approves those actions, like some kind of workflow. These should be considered when deploying an autonomous agent. For example, if you're having an autonomous agent do patching, maybe zero-day patching or hotfix patching, before it does the patches that it thinks it should, maybe there should be some kind of checkbox, some kind of summary that is sent to a manager to say, do you approve this change? Just like you would in a normal change control process, but the AI doing this. And we actually are seeing this already. Very popular AI coder, Darwin, anyone's ever heard of Darwin, actually does this. So before it makes certain code changes, actually creates a summary and gets authorization before it writes and makes those code changes. That's a feature within. So we should be doing that in our apps we're using for organizations. So all of that is great, but we're not here to talk about stock trading apps. We're here to talk about cybersecurity AI use cases. So let's look at, and I know a couple of you are like, more code, Brandon. No, we're going to look at some more code examples. And this one, I think, will interest a lot of you. So AI SymBot in 23 lines of code. So for this one, we're using Google again. Environment variable, we're using JSON this time to parse log files in JSON format. I know a lot of Windows event logs are in the AgentX format. There's lots of different formats we can parse. This is just a specific example, but this is going to be a bot that triages for us. So it's going to input, we have our API key, it's going to read the tail end of the file for the latest event alerts, and it's going to prompt with instructions of gathering and hypothesizing root causes and top indicators of issues. And returning, this is where I said we're being specific on what we want the AI to return. You're going to return JSON with keys, summary, root causes, indicators, and comments. They can take that JSON file, give it to another bot, another AI agent, or another step in the chain, which we didn't talk about here because it complicates the code. Can't fit all the code on slide, but that's where LangChain, which some of you may have heard, comes in, where we actually have a chain of functions within a bot or an AI agent. So the first thing does this, the output from that goes to the next one, the output from that goes to the next one. Sounds a lot like linked lists for those who remember C and C++ coding days. But so 23 lines of code. This is using Python Fire, so it is a command line. So this is an example of how you might build this. Just a quick triage in a couple lines of code using an agent. Now, with that being said, compliance-wise, sending your log data to a third-party AI tool, I want to be clear, I'm not necessarily recommending that. But I'm saying that this is how people are using it from a simplistic viewpoint. Obviously, a lot of vendors out there have hopefully more complicated code than this example, but this is how they're doing it. They're sending this kind of information, getting specific outputs, and that is all the AI tools that are doing a lot of the SIM and analysis. Now, that's great. Let's look at a red teaming example. How would someone use this for hacking, whether our internal team or somebody else? Well, this is a fun one, and I actually like this one a lot. So it's an AI Nmat rogue scan bot. So very simple. It's just you're going to feed in a JSON list of all of the IPs or MAC addresses on your network that are supposed to be there. And then this bot's going to go out and scan and identify any red flags it sees of IP addresses or MAC addresses compared to that list that shouldn't be there, and what the device could be based off the information it gets back in OS detection. And it's going to raise those red flags to you. So pretty straightforward, simple script. Could be highly valuable. Having an AI bot constantly check to see on any network if there's a rogue device on. And these examples can go on and on. There's a lot of them. But the point here being is this, again, is about 20-ish lines of code. And these are simplistic examples. I know many of you in the room, because I only saw 3 or 4 people raise their hand, have done some Python programming. But the idea is clear that these tools are very accessible, not just to us as defenders, but to attackers as well. If we can quickly create tools to triage logs, defend against things, you better believe that that means our adversaries can create tools to hack into systems and autonomously get into other systems more quickly as well. So to wrap this up, summary, Python's a powerful tool for AI agentic bot creation. And make no mistakes, whether we're calling it AI agentic agents, this is the next iteration of what we used to refer to online as bots. They're just a little bit more sophisticated. They use a little bit more math, but essentially that is what this is. Creation of agentic AI should be done, it says down, done with caution. Rain pros, I promise. Well, actually, no, it was my plan all along to have spelling mistakes in here the whole time. Malware threats and attackers can quickly develop their own AI attack agents using these same techniques. So again, it's a quick summary of agentic AI, what they can do, and from a defense and offensive standpoint, what we should be looking for. All right, so will this change the cybersecurity world? Maybe, probably. It's definitely impacting 2025 for sure, but only time will tell. Thank you. All right.